We are finding the inverse in the domain and range. Let's find the inverse first, and then we'll go back with domain and range and talk about that. If we're finding an inverse, the very first thing we got to do if we're finding the inverse is what? Switch the x and the y. So it's going to be x is equal to 2y minus 1 all over 4y plus 3. So we flipped x and y. Once we've done that, Maya, what am I going to do next?
Multiply by 4x plus 3.
Yep.
4y.
Yep. Get rid of that 4y plus 3 out of that denominator. So we'll multiply that to both sides. That's going to cancel. It's going to get me this. I get 2y minus 1 over here. I'm trying to get y by itself. That's the whole goal. We flip x and y and we solve for y. But if I divide by x right now, does that really help me get y by itself anymore? No. And this is one that we did back in the day that we realized there's another way of doing it. And although it seems counterproductive, we are going to multiply in that x. So I get 4xy plus 3x equals 2y minus 1. So I multiply that in. The reason we do that is now we can easily add and subtract the x's and the y's on the same side. So that's kind of the goal here. So everything that has a y in it is going to come to this side. Anything that does not have a y in it is going to go to that side. So I'm going to be left with this right here, 4xy minus 2y equals negative 3x minus 1. Everybody with me to that point? Can I combine the 4xy and the minus 2y? No, they don't have like terms, so I can't combine them. But what can I do in order to get y by itself? They factor out a y. They both have a y in it, so I'm going to factor it out. Then I'm left with 4x minus 2 is equal to negative 3x minus 1. And then finally, divide by 4x minus 2. That's going to cancel. 4x minus 2. That right there is the inverse of my original function. Everybody with me to that point? The other element that we had on this question was find the domain and range. Okay, so let's find domain and range here of this initial problem. If I'm finding the domain is going to be all real numbers. But x cannot be what here? What value can I not be? Brady? Negative 3/4. Why can you not be negative 3? What's happening at negative 3/4? There's a vertical asymptote. He is finding that by setting the denominator equal to 0 and solving. Okay, there's a vertical asymptote if we can get 0 when we plug it in the denominator. Okay, then let's do range. If we're talking range here. Well, actually, let's not talk range. We'll come back to range. We could have done it at this point, but let's come back to it. It'll make more sense here in a second. Okay, now let's look at our other function. It's this guy right here. Let's talk about its domain and range. Domain here is all real numbers, but x cannot be, what value can I not be down here? 1/2, because again, we take 4x minus 2, we set it equal to 0 and solve. X cannot be 1/2. Now let's talk about range. The good news is if you have inverses and you find the domains, which is a little bit easier, that will find me the range. My range is going to be all real numbers, but y is not equal to 1/2. And this one right here is all real numbers, but y cannot be equal to negative 3/4. What is happening at 1/2 up here? Why do I not touch 1/2? There's a horizontal asymptote. Just because I have a horizontal asymptote doesn't mean I don't touch it. Okay, but in this case it does. So my degrees are the same. They're both x to the first. We look at that 2/4. That's why there is a horizontal asymptote at 1/2 that we do not cross. Okay, because of that. Okay, same thing down here. Negative 3/4. Yep, the degrees are the same. We look at leading coefficients. It gets me negative 3/4. Questions there? Here's a picture of that, if you don't believe me, in terms of what that graph would look like. F and G, and then there's the line y equals x. If they are inverses of each other, you're going to have they're going to be reflected over the line y equals x. Would you say that's true? Yep. And we said there was going to be a y or a horizontal asymptote at 1/2. Yeah, you can see on that red line that 1/2 is definitely a horizontal asymptote. And if we did x equals 1/2, which is the other one's domain, yeah, you can see for that blue graph, that is definitely the domain where it's not crossing that value. Questions? Grab your whiteboards. We are doing rapid whiteboard review today. We're going to do a whole bunch of questions pretty quickly, see how many we can get through, and practice. Here we go. Question number 1. Find the value of the function f of x plus a. Find it. Hold it up when you get an answer. Go. Here we go. If we're finding f of x plus a, we're taking x plus a and we're plugging it in. X plus a squared minus 2 times x plus a. What do I need to do if I have x plus a all squared? Foil it. X plus a times x plus a. If we do that, we get x squared plus 2ax. When I do that, and then I do, well, when I do that, and then when I do that, and then I get a squared at the end. And then make sure you distribute that negative to both things. Negative 2x minus 2a. That right there is my answer because none of the things can combine. Questions on the first one? Next one. Write the equation of the piecewise function. So remember, when you make a piecewise function, you need not only a rule for what is the equation, but you need an equation and a rule. You need both things. Do it. Go. Here you go. Write the equation. So the first thing we could do is write the rules. Those are fairly easy. And this one, my x is going to be less than or equal to 1. I can tell that because it's a closed circle. For my red graph there, it's going to be x is greater than 1 because it's an open circle. It's not included. Okay, that's where my break line would be. My break line is at 1. Okay, next thing I'm doing is looking at this blue graph. What is our base function there with that blue graph? Square root. What has happened to that square root graph? Flipped horizontally. Where does the negative sign need to be if I'm flipping horizontally? Inside. So if I write that right there, I also need to shift to the right 1. And the way I'm going to shift to the right 1 is write plus 1. Because again, remember, it's like factoring that out. Yeah, we want to say minus 1, but because of the negative in front, when I distribute it, it becomes plus 1. We would also want to check to make sure it hasn't been stretched. Okay, our normal pattern for a square root is 1, 3, 5. So up 1 over 1, up 1 over 3. Yeah, we're following that normal pattern, so that one's good. Second one, obviously it's a quadratic. It's x something squared. I've been shifted right 2 and up 1, so it's right 2, so it's minus 2. Up 1 is plus 1. But what else happened to that graph? Stretch. My pattern is normally 1, 3, 5, but this case I went up 2 over 1, so I need to vertically stretch by 2, throw a 2 out in front. Questions there, write an equation of a piecewise. Next one, go. Here we go. G of f of g of 1. We start with the inside. We're doing g of 1. So g of 1 is like plugging 1 into this thing. So it's 2 times 1 squared minus 4. 1 squared is 1 times 2 is 2. Minus 4 is negative 2. Then I'm going to do f of negative 2. Well, if I look at this, f at negative 2 is negative 1. Then I'm doing g at negative 1. So if I plugged in negative 1, it'd be the same thing as I plugged in positive 1 because I'm squaring it. Okay, and so my final answer would be negative 2 on that one as well. Questions there? Next one, solve it, go. We look at this problem we're trying to solve. Log base 4 2 times, so what should I do first? Combine them, condense them. If you wanted to get crazy, you could have just said that log base 4 of 4 is 1 and then worked with it that way. That's not what you said, so that's fine. What can I do with this 4 and that x minus 4 then? So 4 times x minus 4 is going to be all equal to 3. Then I want to get rid of the log base 4, so I'm going to raise both sides to a base of 4 and make it an exponential. So 4x minus 4 is equal to 64. Then I'm going to divide both sides by 4. Divide by 4, so I get x minus 4 equals 16. And then I'm going to add 4 to both sides, so x is equal to 20. There's lots of different ways of getting that answer. That's the way I would do it, but you can do it lots of different ways. As long as you get 20, you're good. Questions there? Next one. Find the half-life. Go. All right, so this is one that it looks like we need a little more practice with. Y equals AEKT. Remember, when we do half-life, the best way to approach it is to split your paper in half. Okay, the first time through, we're talking about half-life. So how much should I start with for half-life? You could start with 1,000, or I would just start with something simple like 2. If I start with 2, how much am I going to end with if I'm doing half-life? 1. Okay, E, K is what I'm searching for. The first time through, we're always searching for K, and the time that's going to elapse is 48 years. So obviously, I divide by 2, divide by 2. So 1/2 equals E to the 48K. How do I get rid of E? Natural log. The opposite of E is natural log, so we're going to take the natural log of both sides. That's going to cancel. No, I'm just kidding. That's not going to cancel. That's going to cancel. And then I'm going to take that number and divide it by 48. That's going to get me my k value. So in my calculator, okay, I'm taking the natural log of 0.5 and I'm dividing it by 48 years. I type it in, I get that right there. Does it make sense that my k value is negative? Yeah, because it's decay. Okay, that's the rate of growth. It's not growing, it's getting smaller. You could write that k value down if you wanted to. It's negative 0.014. But I'm not really going to write it down because I don't want to round it. I'm going to leave it in my calculator. Now that I've found that, and then I'm plugging back into this guy, now I'm actually solving. So my A this time is going to be 1,000 grams. That's how much I started with. I know what my K is. It's that number right there. And my time is going to be 200. This time through, all I got to do is type it in. So it's 1,000 grams. E to the K, when I'm just go up there and select my K, times my time, which is 200. After 200 years, 55.681. We always go to 3 decimals. 55.681 grams are going to be left. Questions there? Half-life. Double check it if you're not great at it. Let's do these. Write the exact value of each. Do A, B, and D real quick. Try those 3. Go. Looking at the first one, sine of negative 240. If I'm doing sine of a negative, does that negative matter?
No.
Yeah, so we could pull it out in front. So it's the negative sine of 240 degrees. If I'm doing 240 degrees, that is that line right there. So 643. What's your sine value going to be? Radical 3 over 2. Is it negative if I'm in the third quadrant? Yeah, but I have a negative sign out in front, so it's really going to be positive. Cosine of 5 pi over 3, that's in the third quadrant, or fourth quadrant, sorry. It is that guy right there, that's 5 pi over 3, so again, 643. My x value is going to be 1/2. Is it positive or negative? Positive, so that's 1/2. Secant of negative 300. Does a negative matter if I'm doing secant? No, because that's like cosine, so this negative sign doesn't matter. So again, I'm talking about that angle right there, 300 degrees is that one. That's, again, that 1/2 value, but we're going to flip it since it's secant. My answer is 2. Questions with sine stuff or trig stuff? Try this one, right? 2 different equations for that following graph. You can get to pretty fancy equations. You can make this pretty tough. Make it easy on yourself the best you can. Go. Again, this one could get pretty ugly if you wanted it to. We're trying to make it simple the best we can. What graph would you say this is as you look at it? The easiest one would be tangent. Okay, so we would set that up. If we talked about period length, what would you say the period length is on this graph? 8. Okay, in between -4 to 4, it is a period length of 8. What is our base period length of a tangent graph? Pi, and then you would have to multiply by something and get 8. So I want to know what this mystery number is. To find it, I'm going to divide by pi on both sides. So I get 8 over pi is what that mystery number is. But what am I going to do with it if I'm putting it up here? Do the reciprocal. It is pi over 8x. Obviously, I've also been shifted up 2. That is going to be my equation. Okay, that would be the simplest way of writing that equation. If you had to write a second equation, I would do it really simply. Okay, I put a negative sign right there. Does that negative sign affect my graph?
No.
Yeah, it does. It flips it. But what happens if I put a negative sign in front as well? Now I flipped it twice, so it's going to match. At other answers, here are some other answers we came up with earlier. So we had that cotangent of negative pi over 8 plus pi over 2. The key there is you can't just have a number here. Saw a lot of people like adding 2 or 4 there. It's got to be some term of pi. Because remember, whatever you do there, you also need to multiply that by the reciprocal of whatever's in front of your x. That's a phase shift. So somebody had like negative cotangent pi over 8x minus pi over 2 plus 2. Somebody just had that one. It also matches up. They're all the same. Other questions there? Anybody want me to check one that they had? Yes, sir.
Well, so what did you know? Check it, but so what do you have to set up there to like get the phase shift?
Remember, so the easiest way to think about it is if we did cotangent, let's do this second one, this last one we just had. So negative. We know that there needs to be a pi over 8. Take that pi over 8 and throw it out in front of the parentheses. And then you could be like, hey, where's that graph? Well, it's centered in the middle. but I really want it to be, or normally it would be an asymptote right here, but I want to move it all the way to 8. So how would I move it all the way to 8? I would subtract 8. No, would I not subtract 8? Subtract 4, my fault. Subtract 4 because I'm, yeah. Oh my gosh. There we go. And so that right there, what's the difference? It's just distributing the pi over 8 into it. And that it's going to get me the same setup. That can be pretty tough. I know that's pretty tough. Questions there? All right, couple more. Find all the asymptotes and the holes of that thing right there. Go. Find all the asymptotes and the holes. Find the asymptotes and holes. What do we want to do first here? Factor. If we factor this thing, we get x plus 3 and x minus 4. And on bottom, we would get 6 and x minus 4 and x plus 4. So I'm going to have a hole at x is equal to what value? X is equal to 4 because it would cancel on top and bottom. I have a vertical asymptote at x is equal to what value? Negative 4 because this would be equal to 0 on bottom and it wouldn't otherwise. I have a horizontal asymptote at y equals what? Why do I have a horizontal asymptote in this case? Degrees are the same. What about an x-intercept? I have an x-intercept at x is equal to what here? Where would my x-intercept be? Negative 3 because you set the top equal to 0 to find x-intercepts. Set the bottom equal to 0 to find vertical asymptotes. Set the top equal to 0 to find x-intercepts. Questions there? All right. Good stuff. Whiteboards.